Hello, everyone, and welcome to the Carbohydrate Chronicles, a podcast about glycoscience and glycoscientists. In this show, during a series of interviews, we explore the world of carbohydrate science and innovation from a personal point of view. Your host today is Tamas Shahida, member of Carbohydrate Scientific Team. Glycoscience is the study of carbohydrates, sugars, and their roles in biology. Glycans play critical roles in many biological processes such as cell signaling, cells adhesion, immune response, protein folding, and a lot of other fields. And glycan analysis and characterization is an increasingly important area for biopharma, as understanding glycan profiles helps in development of new therapeutic agents. Structural analysis of glycans and complex carbohydrates in particular, that of lipopolisaccharides and glycoconjugate, is the expertise of our guest today, Anthony Molinaro, professor of organic chemistry at the University of Napoli. This show is supported by Carbohydrate, where it is important and essential not only to get familiar with the research, but the researcher itself. In our series, we invite key opinion leaders of the glycoscience field, both from academia and industry, working on various angles of carbohydrates. Over the course of 16 weeks, we'll publish a new episode of altogether 16 interviews as parts of our first season. Now you're listening to the very first episode, and all the future recordings will be available online at Apple Podcast, Spotify, and Google Podcast. Today, I have the great honor to welcome Tony Molinaro, a renowned scientist in the field of carbohydrate analysis. Welcome, Tony, and thank you for accepting our invitation.
Good afternoon, Thomas. Good afternoon, and thank you for the invitation.
By way of a short introduction of Tony, he focuses his research on the isolation and structural determination of carbohydrate-containing molecules, and he has published almost 300 papers in this field. He also published research in top-ranked papers, serves in the editorial board of others, including Carbohydrate Research and Glycobiology, and is the chairman in several regional, national, and international projects on structure and function of microbial glycoconjugates. Tony, when learning your background, I saw that you started your studies in biology and chemistry already in Naples, and you're still there. So are you a local patriot, we could say?
No, not really. I mean, I've been back in Napoli after some experience abroad. I've been learning LPS, lipopolysaccharide science in Borstel, close to Hamburg, from 96 to 2002, not 6 years continuously, but let's say 6 months per year for 6 years. So I've been there for a while to learn the LPS topic, the LPS science. And then I've learned a little bit more of structural biology in terms of NMR in Madrid with Jesus Jimenez Barbero. Then back to Napoli.
How is life in Naples nowadays? I just saw a headline about an actor eating pasta naked on the street because he won the soccer championship. Is that
well?
Right?
I mean, if you're asking about the, let's say, social life, not scientific life, now we are at the top of the pop because we won the Italian championship, and this was the third time for us, only the third time, and was the first time without Maradona. So for us, it's a new era, and we are all happy because let's say when the championship goes to South, we are very happy. But it's not so often that is happening. This, and the actor was walking naked because that was a promise in case. But that was it. We are happy at the moment. We are happy.
Yeah, I can imagine. Are you a soccer fan yourself?
Absolutely, yes. It's part of the education here in Napoli. You cannot skip it. You can. There's a clear cut. I mean, thing that you have to learn that is soccer with absolutely no discrimination in terms of gender. Everybody know about soccer.
That must be indeed a festival season, a true celebration, and for the whole region.
Yeah.
Getting back to your education, so why have you chosen science as a profession? Was it something that you determined in your early years already, or it just happened? How was it?
I mean, if you're speaking about how did I choose science, generally speaking, this is just coming from my high schools, because in the high schools I was much better in chemistry and in physics than in other, let's say, topics like Italian's literature or whatever. Okay. Then I decided to choose biochemistry just because let's say my former fiancé chose biochemistry, so we decided to go together there. It was not a real, let's say, thought choice. It just was by chance. But it was love. But I mean, anyway, biochemistry was in the middle of my interest, so there was not a let's say an unfair bet. I knew what I was going to do, which was also a good choice because then I realized that was really interesting for me, and then that's it.
And when have you got deeper into structural analysis?
This was during my PhD because I started, just already during the master degree thesis, and then following with the PhD, I started to work with natural compounds deriving from plants. And at that era, I was working a lot with lipid extract, chloroform extract, ethyl ether extract, and etc. The most, let's say, outrageous compounds were deriving from the methanol side, where they were already polar, not like polysaccharide, but maybe they were bearing 1 or 2 sugars. And so this was my, let's say, coming into the carbohydrate world. But that was starting at PhD level already, dealing with NMR and as mass spectrometry of little compounds, but already, this forma mentis to approach these things.
So you entered the world of carbohydrates step by step, sugar by sugar?
Yeah, exactly. Increasing the polarity.
I see. I see. And was it your choice, or you found them fascinating when you did all these analytical studies?
Let's say I was accompanied in this choice, but it was my choice. I found a good mentor, and he helped me to learn about, let's say, very, very polar molecules. And then I decided that this was the thing that I liked more. And then I went through this from a lot of different points of view.
At Carbohydrate, we always say that carbohydrate chemistry is the most complex among all.
Yeah.
But when we start creating a molecule, we always say that, okay, the chemistry will be complicated, but the analytics, that will be a nightmare. So that's not for the faint-hearted. Would you agree?
Absolutely agree. In generally speaking, I think that carbohydrate chemistry is the most complicated one, and the analytical part of carbohydrate is still more complicated as possible because there's no automated methods. There's nothing that you can use. Every time you have a white powder, you have to start from scratch with wet organic chemistry, starting from zero. I mean, you don't know that there's no button to push and then you go away for a beer. You have to stay in the lab and use the maximum of your knowledge to try to get what nature is doing, especially at microbial level. It is always a surprise, always bizarre chemicals you find, always like this.
What is it that fascinates you in the chemical analysis? So where do you find the joy in it?
What I like a lot is to discover new sugars, because it always reminds me that microbes are more complicated than eukaryotes from the biosynthetic, from the chemistry point of view. It seems weird, but it's like this. Eukaryotes, especially, let's say, mammals, they have only 12, 13 sugars to build up whatever. Instead, prokaryotes, they have at least 200 and more we discover, etc., etc. So what I find fascinating is the fact that I discover new structure. This is, again, deriving from my PhD studies, because I found fascinating the fact that I could discover new compounds from plants or from fungi or whatever. And it's still like this. It's just new discoveries, new chemistry.
Learning something new every day can be really stimulating, I think, for a researcher. Do you have a favorite technique that you like to use most? I understand that you need to combine different analytics, but do you have the one?
Yeah, NMR is my method of choice.
And then why is that?
For several reasons. Because NMR is giving you the view of a molecule when it is in solution. So in case of biomolecules, it gives you a real sketch of real life behavior. in the recent years, in the last 15 years, we also doing molecular recognition studies by NMR. So we also doing protein carbohydrate interaction. And this is very interesting because it gives you the clue, how the molecules behave when they are in their native solvent, like water, buffer, etc., etc. That's why I like a lot NMR, even though I know very well, because I also teach NMR to the people, that is not a sensible technique. So you must have a good amount of sample to have, let's say, good information. It's not like mass spectrometry or other techniques. But still, I think just because I'm in this case, I'm biased. I like NMR more than the others.
I agree with that it has a sense of real life information,
Yeah.
and it also provides some information on structural interactions that no other analytical tool can meet.
Exactly.
During your career, you have spent time at different institutes as visiting professors, Germany, UK, Spain, even Japan. Yeah. Do you find it important to widen knowledge abroad for researchers? Is it critical, in your opinion?
Yeah, well, it is very important if you choose the right lab. I don't believe in the dogma that you have to go abroad just because you have to go abroad. And nowadays, with these short distances and the cheap flights, you can go anywhere, anytime. Okay, at least in Europe, we always say that in Napoli, at least because we have a huge traffic jam, that probably is better to go to London to work and then come back in the evening than to go to university and come back, because it takes the same time, but it's less stressful. However, the thing is, if you make the right choice in terms of lab, in terms of expertise, then it is worth to go abroad. But I don't believe in the fact that you must go abroad in any case. This is maybe important. Maybe it can be more important in terms of opening the mind of the person to other ideas, to other, let's say, environments. But I don't think this is mandatory for science. I mean, if you are working in a good institute and the things are going good and your institute and your science is competitive, then you go abroad only if you want to learn a specific thing, and then you pick the specific lab.
I get
Hope
it.
I was clear.
Yes, definitely. Okay. And among these trips, is there one that's, I don't know, the most memorable
in my case,
for you?
Yeah. In my case, well, I mean, in Japan is different because there I have a teaching position, so I have to go. And it has been really worth to stay there because Japan is, in terms of approaching science, is completely different from the European thing. So it is worth, and I got a lot of very important, let's say, results in terms of outcome for my science. To the other institute, I've been there just for specific things, to learn specific things. And I will do it again if I think I need it. If there's, for example, a new special approach for NMR to learn, which can be worth to apply to carbohydrate, I will go. Otherwise, I will stay here.
And have you ever thought about doing some work in the private sector, or have you done any work in the private sector?
No, I've done this. I have not done this. This is an experience which I'm missing, but not because I chose it. Just I had no occasion to do it.
But do you regret?
Or I think so. It would have been another experience for me. I don't have any, let's say, preformed idea about this. So I don't think that the private sector can be different from. I have a lot of interactions. I mean, myself, I'm not doing this for the private sector, but I have a lot of interaction with vaccines companies here in Italy, GSK and et cetera. They work with us on carbohydrate, from microbes and et cetera. So I interact with them. So I know how do they work, and it seems to me very specular. So I don't think it would have been that, outrageous or strange for me. Simply, I didn't have the occasion when I was young, and then I developed my academic career, and that was it.
Tony, what do you do when you're not in the lab? In your free time, what do you like to do?
Listen to music, rock music. I'm a runner, so I run every day, and I like to go to visit places by running. So that this is something that I always do. I travel always with my things to run, because I think it's a different way to look at the things, to look at the cities, to visit the cities, and et cetera. What else? I like cinema. I read books, and I have family, so I do a lot of, let's say, very normal, boring, canonical things, but still I like them.
I think that's boring. That's a very active life, apparently.
Yeah, it is. It is. I'm not a good sleeper. I sleep few hours and I like to stay awake and doing a lot of things. Maybe everything's superficial, but I like to do this.
Among the projects that you have worked on or what you're working on nowadays, if we look a little bit more into the science part,
Uh-huh.
what is that you're currently most excited about? What kind of research that you're going deeper into, where you see, I don't know, breakthroughs coming?
Well, at the moment,
Yeah.
what I'm working on and what I think it is important is I want to shift the paradigm of LPS endotoxin. Uh, you know that LPS are, let's say, always being thought as harmful, bad molecules, because they elicit innate immunity, till the sepsis, and etc., etc.
Yes.
But you know very well that we are full of microbiota, and the microbiota is full of LPS. So I want to understand how the LPS from our microbiota do not work in terms of elicitation of innate immunity. And I think that the chemistry behind this is pivotal to understand. And I think that the structural elucidation of the LPS from gut microbiota will tell us that there are good LPS and bad LPS. But LPS itself is not the paradigm of a bad molecule. And understanding this probably will open the way to new drugs, because once you understand what is bad and what is good, you can tune this, synthesizing new molecules with the proper epitopes.
Yeah, that's a very fascinating research area. If you look at this research from an outer perspective, where do you think you are on the scale of truly understanding the role and the nature of these structures from 0 to 100? So are you at the beginning of the road, or you already?
No, I don't think we are at the beginning. Well, I mean, let me do another premise. The thing of the LPS I mentioned before is related to the microbiota. You know that now every time you open a scientific text, you read about microbiota, which seems to sit at the crossroad of every phenomenon. Okay, but what I think is that every organism is interacting with microbes in any way. I mean, humans with the gut or with lungs, plants with the root on the leaves, and there is always interactions, always an open system in which the microbes are interacting, either by symbiosis and commensalism or by pathogenicity. There are a lot of studies. Then I come back to your question and my answer. There are a lot of studies about this, and there are a lot of things are very well understood from the immunological point of view, the phenomenon, the immune cascade, and the reaction, etc., especially on, let's say, mammal side. On plant side, it's a little bit lower in terms of knowledge. But however, very few scanty information are about the chemical level of these things. What I want to feel is the fact that we miss the molecule acting, eliciting or suppressing the innate immunity, and then allowing a microbe to interact in positive way with a eukaryotic organism. So I think we are maybe at 50% of the path, and I want to add the other 50%. I didn't contribute to the first 50%, to be clear. But I think that the chemistry knowledge is missing, and it is fundamental.
Yes, that's a fascinating journey and a huge challenge for you. It's not an easy task to undertake.
No, but I like to dream. So, I mean, this is also something that I do during my spare time, to answer to your former question.
So these ideas come to you when you run and listen to music and
Yeah.
If you look back to your career, is there any, I don't know, a specific project or an accomplishment that you're particularly proud of in your scientific works?
Well, in this case, I can tell you that what I'm particularly proud of is the fact that I have demonstrated that microbes are really intriguing sugar factories in terms of weird chemistry and stunning molecular, let's say, architectures. And this is something to which I really contributed, and for which I'm really, let's say, not really known, for which I'm a known person in this field. And this is something that I think it is the part on which I have a major, let's say, contribution, and I'm very proud of this.
Yes, and those kind of research are somehow the fundamentals, the building blocks of now subsequent studies.
Yeah. The microbial recognition from the eukaryotic host, which is fully based on the chemistry.
Yes. And how about failures? Do you have any painful lessons that you learned from?
Well, I mean, I'm not a big success guy, and I can tell you that every success I have there are 100 failures hidden. So it's something that I always try to teach to my, let's say, youngsters. Next time, fail better. And this is the thing that I always say in the lab. And when you fail, don't worry. Next time you will fail better. And this is something that it is very important. A scientist has only, let's say, attribute as to dream. Okay, so when you dream, you are okay as a scientist. So the only thing is this, and then you apply your ideas, and you will fail once, you will fail twice, 13, 14. This year, I got a European project. I don't want to speak about this, but I got a grant for a European project. I tried 14 times the last 14 years.
14 times?
Yeah. So, I mean, and what I'm trying to teach to the people is just you have to try, always to try, never fail. And
so you are a persistent guy then?
Yeah. I think the persistency is one of the most important things. And the persistency, my friend, is the secret to live long. This is microbes teaching is this to us, okay? The most important microbes, the ones that they are able to live in every conditions, they lose the cell wall and then become persistent. They will survive to everything.
Okay, that's a good takeaway. So persistent is the key to survival.
Yeah, it is.
Last question about science. Thinking about carbohydrate analysis, how do you see the future? Where this particular area will develop in the near or longer term future, and how will we use carbohydrate analysis in the future?
Well, since every cell on the planet is completely surrounded by carbohydrate, I think that carbohydrate analysis will always be important and precious to understand the interaction between the cells at any level, okay? Immunology, agriculture, medicine, pharmacy, drugs, design, etc., etc. So I cannot see that I see a bright future, but I see a long future. I don't know if it is bright or not, but it is really long in terms of time because it will be always necessary. Something more important, I think, is the fact that with the advent of new approaches, especially solid-state NMR and other similar cryo-EM and other similar approaches, now structural biology of carbohydrates can be good also for material sciences. And then, you can descend from the supramolecular architecture to the molecular architecture of a material and also at the let's say, molecular level. And this is very important for the new generation of materials. And I think that carbohydrate structural biology is very important for this.
Speaking about new generation, do you have any advice for young scientists who are just about to start a journey in this field?
As I said, I mean, what I can suggest is never surrender if a project fails, never surrender if something is not working in the lab. And science is like this. I mean, you have to dream, and not always everything is going well. And if everything is going well, start to be suspicious because probably something's going wrong and you didn't care. Okay, but this is the thing, and I have no, let's say, dogma or paradigm to suggest. I think it is important to be yourself and enjoy with science.
That's a very, very nice piece of advice, and well, it does sound easy to take, but I know that it's not easy to take it.
Exactly.
Another question that I'm asking all the guests: if you could have dinner with any historical figure or celebrity or even fictional character, dead or alive, who would it be and why?
Well, I mean, if I have to have a dinner with a non-scientist, I would like to have a dinner with a living person, a still living person, who is Mick Jagger, the singer of the Rolling Stones.
Oh,
I would like to have been told all these stories, either Mick Jagger or Keith Richards, or maybe both. Okay, if possible, I could pay both a dinner if they could tell me their life, because I think it is something really fascinating from all points.
So you don't want a dinner; you want the whole weekend, at least.
Yeah, probably it's necessary. It's necessary on the weekend. You're right. As for the scientific part, probably I would like to have a dinner with Marie Curie, because I always appreciated, let's say, her, once again, persistence in working on the things and dedication to science, which I think is a model for everyone, to be happy to work and with the things and to work with your dreams. It's the secret for being successful.
So that was the last question I had. I hope you enjoyed the first episode of Carbohydrate Chronicles today, delivered to you by Carbohydrate. We talked with Tony Molinaro, professor at University of Naples and expert in carbohydrate analysis. As Tony pointed out, this field is not absent of challenges, yet to understand the mysteries of our world and our body and the crucial role of microbiota in our lives, tireless efforts are needed, and this is what Tony and his group devoted to life at the heart of Naples. And as we can clearly see, it's with a lot of passion, cheer, and joy. Thank you, Tony, for being today with us. This was a stimulating discussion, and I really loved those lines. Next time you fail better, and persistence is the key to survival. So I really hope to see you again soon. Thank you again.
Thank you, Thomas. It's been an honor to discuss with you. Thank you to everyone. Thank you so much.
Next week, in the next episode of Carbohydrate Chronicles, we'll talk with Thorstein Loftsson, one of the world's most renowned experts in cyclodextrin-based drug delivery, professor at Iceland University and founder of Oculis, an ophthalmic pharma company just recently being listed on NASDAQ. Your host was Tamás Sohaida from Carbohydrate. I hope you'll join me in our next session too. See you in 1 week. Goodbye.